What's up, goofball? So, hey, man, hope you're doing well. I'm going to try to help you out here. I figured I'd send you a video. I'm going to try to make it on Tuesday with you, but things are crazy around my house with the three little ones doing virtual and all that. So I'll try to hook you up. So, um, hopefully this works. So, let's see. Get this thing going. Check this out. All right. So, hopefully this is recording on the screen. So, it looks like you needed help with circles and area and circumference and stuff. So section's actually really easy. So it looks crazy and it looks hard and scary because there's a bunch of different like symbols and all that. Some of the teachers try making it sound fancy. It's not. Okay. So two biggest things you need to know is radius and diameter. Okay. So the radius and diameter are the radius is obviously halfway across. I'm sure you've learned that. And then the diameter would be all the way across. Okay. As a kid, I always used to write these in lowercase letter. It helped me because the smaller one, this one doesn't go as far as that. So this one doesn't go as far as the diameter does. Radius is halfway across to the center point. Diameter from point to point on a circle going through the center point. Okay. So these are critical, but they're easy. So radius small, diameter big. Little letter, big letter. Okay. As far as circumference, we'll start off with circumference because that one was easier for me as a kid. So you start off with a circle, right? You have your deal here. Okay, usually they're going to give you a circumference or radius or diameter. I'm sorry, and it's provided to you usually. Sometimes they'll make you work it backwards, but regardless of the fact, all circumference is here's the fancy little formula. Circumference is equal to this pi times d. So it's like what? Okay, so it looks funky. It's really simple though. Okay, what they're actually asking you to do is in order to find the distance around a circle, right? If I gave you like a rectangle, we'll start backwards a little bit. I could take a ruler and measure from here to here, ruler from here to here, ruler from there. So you get it. Okay? So I could actually measure this out. If this is 4 and this is 2, I know from here to here is 4, from there to there is 2, there to there is 4, there to there is 2. Over here, that kind of falls apart. I can't just take a ruler and measure this out. There's only one thing that I can actually measure on the circle itself, on every circle, and that's these two dimensions. So I can measure the radius and I can measure the diameter. So they were trying to figure out, well, how can we measure the distance around like a circular object without getting a ruler out, with just like eyeballing it? Or is there a dimension we can use inside of it? So they found that if they take the diameter of a circle, they take this distance from here to here, across the center point, right? All the way across the center point. Well, if they took that, they figured out that this pi, this number pi, is not magical. A lot of kids are like, "Ooh, what's pi?" It's really not magical. Okay, what it really is telling you is you're taking this diameter. Okay, we'll just pretend it's 10 in this case. So d is equal to 10. Radius would be equal to 5 on this guy. Okay, just so you have some reference points. What they found is if you start off, pretend this is like flexible. If you took this and you wrapped it around the circle to this point, that would be 1 diameter. Okay? Take another one. It wouldn't wrap all the way around the circle. Take another one, wrap to about there. So that's 2. You took another one, you kept unwrapping it, wrap to about there. Okay? This is 3. So 3 full diameters. So this is really 10. This is really 10. This is really 10. That's literally what you're doing. That's where this comes from. 3.14 times, that's why it's multiplied by the diameter. So you can really think about this in distributive property terms. 3 plus 14% or 14 tenths times 10. So I've done that. I've done 10 times 3. 10, 10, 10. That's where we get to 30. This little gap, this little guy right here is literally 0.14% or 14%, 0.14, 14 hundredths of another one of these. So it would literally be like a little bit over a tenth. So between a tenth and a 20th, between a tenth and a fifth. So it's about 14% of the diameter. Well, 0.14 times 10, anything times 10 is just shift the decimal over, so this would be 1.4. So this guy is 30, and then this guy would be 1.4. That's literally all it's saying. So it's 3 diameters, 3 full diameters, whatever that number may be, And then you're going to take 14% of that last diameter. You can use your calculator, or you can just multiply it by 1.14, whatever it would be. So if they give you another one, so they give you a little bit of a strange one here, they give you a radius. And I need to find the distance around. I can't use the radius because that's not going to help me. I could, but I'm going to have to multiply it by some crazy number, and you don't want to do that. So I extend it. Okay, so if my radius is 7, I know my diameter is 14. It's the same process. I start from here. There's 1 diameter. There's 2 diameters. There's 3 diameters. And then I have another 0.14 of the diameter. So 1, 2, 3. Well, in this case, the diameter changed to 14. So this is 14. This is 14. This is 14. And then I have to take 0.14 times that. So instead of playing with that, they gave us a formula for it where C is equal to pi times D. You don't want to use the radius and circumference because we want to find out how many diameters wrap around that circle. Okay? So if I took 3.14, that's 3 whole diameters and another 14%, multiply it by our diameter, which is 14. So 3 of those plus another 14%, 43.96. So the distance from here to here, the distance all the way around this thing would be 43.96. That's where they're getting that. All right? So hopefully that makes a little more sense. Just don't overthink it. Circumference that's like P. That's like P in math, perimeter. They call it circumference because it's like it's not a straight line. But remember, I walk 1 diameter, 2 diameters, 3 diameters. I take the last one and multiply it by that 0.14. That's it. Whatever that number is all the way across. They give you a radius, who cares? You just double it. You're always looking for D in that. Sometimes they'll get fancy and give you a circumference. Okay, well, you just work it out. You just divide that circumference by pi, and it's going to spit out D. So anytime I need to solve for that, so just got an extra minute here. I got 15 minutes on this screencast thing, so I'm just going to give you one. So let's do 4. Okay, so say they did this. So 37, that's the circumference this time. Let's say they said, the circumference of the circle is 37.68. Well, it's still equal to pi times, or I don't know what I'm doing, pi times D, right? Circumference is equal to pi times D. Well, in this case, they gave me C. Well, I know this is a number, so 3.14. You can really think about it in terms of X is equal to 37.68. 3.14 times something is that. Well, in order to get that, you divide it, you divide it. Or you can really think about it, how many things would go into that? 3 things goes into this, about what, 12 times, somewhere in there. So I'm going to guesstimate our diameter is probably going to be around 12. Let's check it out. So I know 3 of those would wrap around. Well, it's got a little extra change. So I take 37.68 and I divide that by 3.14, spits out 12. So you can really cheat a little bit, especially if they're whole numbers. If your teacher's giving you a worksheet and it's all pages, just remember 3 goes into this approximately 12 times. So 12 plus 12 plus 12. There's a little bit of extra stuff. That's that 1.68. Okay? All right, area. Area's a little fancier. So they gave you a circle. And the old ancients said, hey, we want to find out, what if I need to cover the circle with squares? That'd be pretty rough because it's a circular object, but it's possible. So what they came up with is they said A is equal to pi r squared. Okay? Looks scary. It's not. Think about area. Area is literally covering an object with squares, period. I don't care what you give me. You give me a rectangle, square, trapezoid, triangle, circle. You're covering the object with squares. Big deal. Okay? Well, they gave us a diameter or a radius. Those are the 2 things I could choose. Okay? Well, I can kind of draw a square on here. I can start out by using a radius here. And I can draw a radius there. Okay? Mr. Fisher, that's not going to help me. I don't see any squares, dude. Well, if you extend this out, though, this does make a square. Okay? I get it. Some of this is not included, but this is the concept. So let's just say that this was 2. The radius was 2. R is equal to 2. D is equal to 4. Big deal. When I find area, I always want to use the radius because I'm going to square this. I'm going to make a square. I'm going out 2 this way and 2 this way. Okay? That makes me 1 square out of my, if you look at this, out of my 3. There's my square. I don't know what the radius is, but I'm going to take the radius and square it. I'm going to go square it this way and this way so I can make a square. Okay? So I'm not playing with that 0.14 yet. Here's my next square. I go out this direction. Again, 2 times 2. That's this part squared. I'm multiplying it at least 3 times. And then the last one here is over there. Okay? And there's some extra shaded stuff here. This is not included in our circle. Keep that in mind. I haven't covered any of this crap yet. Okay? I've multiplied it 3 times so far. I've taken the radius and I squared it 2 times 2. So if this was 2, it would look like this. A is equal to pi r squared. So A is equal to 3.14 times 2 squared. This is my square, though. It's 2 by 2. It's 2 by 2. Okay, there's one of them. There's 2 of them. There's 3 of them. That's part of the pi. Remember that 3. Well, where does this come into play then? Well, if you think about it, this whole thing, had I shaded this whole square, if I just did 2 squared, gives me a square, literally, at each and every time. Every circle works like this. I don't care what the radius is. You're going to square it. Is this length is this length. Well, if I have 1 square here, I have a second square there, and I have a third square there. If you notice, this shaded part, and this shaded part fills into this. It actually fills this entire thing up. But I need to figure out, well, how much is this of a square? It's right here. It's this piece here. It's 14% of the 4. So it's 14%. Literally, if you took this, and this, pretend it's like a little, like it's water, I would pour it in, it would fill up a little bit. I would take this, fill it up a little bit. Take this, it would fill up 14% of another square. That if say we unplugged it, it would literally fill this section here. That's what I'm trying to explain to you. Okay, so again, let's try it one more time. Got about 3 more minutes here. So if I have this, we use a diameter this time. Say this was 10. They say find the area. I don't need to overthink this. A is equal to pi r squared. I want to think about it in terms of a kid. I need to make a square. I'm making a square up here. Well, how long is this line? If this is 10 all the way across, this is 5. That's 5. That's my square. So 5 squared. This area is 25. This area is 25. This area is 25. That's the 3. But I got this stuff, my 14%, my extra little bit of stuff. I take it, I dump all that crap in there. This is 14%, 0.14 of this square, one of those squares. Well, what's 14% of 25? So if I did 14% times 25, and I did the 3 times 25, I'm using the distributive property so you can see what's going on. This is 25, this is 25, this is 25. There's the 3 from my 3.14 right there. So you can do that in your head. 25 times 3 is 75. I can't do this in my head. 14% of the next square. Had I had another square here, it would fill 14% of that next square. Because this is a little bit, this is a little bit, this is a little bit. So 14% of that. In reality, what they figured out is we can just combine those. We can just do 3.14 times 25, and it'll give us the same thing. So just to prove this, get the calculator out. We'll do it the old school way. 3 times 25 is 75. 0.14 times 25 is 3.5 for a total of 78.5. This takes all that crap away. Pi times the radius squared. This gives it to you all in one answer. 3.14 times 25, 78.5. That's all it's doing. But they give you a diameter, and then they might try to get fancy and give you the area. They might say 78.5 is equal to pi times the radius squared, and they're going to say solve for r. I did as a kid, as I would say, 3 times what gets me around this? 3. I'm not gonna use 3.14. I'm gonna say 3 times something gets me around this. Well, 3 times 25 gets me around that. Well, what times what is 25? So some number, so radius times radius equals that 25. I know the radius happens to be 5. You might have to use your brain. Hopefully this makes sense, man. I'll try to catch up with you on Tuesday if I can. I can't promise anything, but I'll try to get with you at some point because I know you're a good kid. I know you're reaching out for help, which is awesome. Tell mom and dad I said hi, and stop stressing, dude. Stop stressing. Be a kid. Be a kid, dude.